Hi, so I think I'll do a quick video on the graphs, possibly just one, maybe two. So let's have a little look then. The diagram shows part of a graph, and we need to write down the values here. So the thing you need to remember is that this first value is all about the height. This is how many. In fact, you know what, I'll write this neater. Sorry, this is going to be, that's already messy, right? So this first one, it's almost like the height. Almost the height. It's kind of the height divided by 2, where the height is this full bit here. This is how many waves, so how many are in 360 degrees. And then this is how I moved you up or down any. Am I going up or down? Okay, from, because it should be symmetrical, shouldn't it? It should be nice and even. Have I moved you up and down? So let's look at this one then. What is the height divided by 2? Well, the full thing is 6. Divide that by 2 is 3. So I know that P is going to be 3. It should be symmetrical. We should have a 3 and a negative 3. If that's the case, if the height is 6, 6 divided by 2 is 3, so it should be 3 and negative 3. So our graph really should be looking like this. But someone has moved it up by 1, haven't they? Plus 1. So R is plus 1, we moved up by 1. And then how many are there? How many waves inside of 360? Well, 360 is 2 pi radians. 180 is pi radians. And that then is 90 degrees. So I've got one wave in 90 degrees, which means I'm going to have 4 waves in 360. And that actually is almost everything you need to know about the waves. I don't think it's quite a nice question actually. So how high, how many, up or down? Let's try a few more together. So again, have a read at these and then pause and we can chat through stuff. So this one's saying this can be rewritten as this. Okay, so if that can be rewritten like this, what that's saying is that the maximum of that is 2, isn't it? So 2 and negative 2. And this is your phase shift, which we're not looking at in this one. So we'll get 2 and negative 2. Okay, so something like that, but it's been shifted to the right. We'll come into that in a sec. The maximum value is 2. Yeah, well, I just told you that, didn't I? Because 2 is there. So actually, you really need to know that. But now it says, what's the maximum value of this? Okay, well, what's different? In front of here, there was nothing, was there? There was nothing, but the maximum value is still 2. Now we've got a 5 in front of these values. So what's happened? Well, it's been multiplied by 5. So if I take my 2 and times it by 5, my new graph is going to be 10. 10 and negative 10. Because this is multiplied by 5. If I multiply this by 5, that becomes 10. Okay, nice. I like that question, just to make it a wee bit, wordier and just to make you think a little bit. Okay, what's the equation of the graph? So basically fill in A and B. So what's the height? Well, the height is 2. So that's going to be 2 in there. That's nice. So A is equal to 2. Because, and it's even, we've not moved it up or down, nice and even, so there's no plus C or anything, that's fine. And then how many have we got? Well, 2 pi is 360. So we're just counting the waves this time. Okay, so there's 1 wave, there's 2 waves, and there's 3 waves. So B is equal to 3. So that's going to be Y is 2 cos 3x. Simple as that. On we go to the next one. So what's the range of values? Okay, well, all that means is what values of fx, what values of x is the max and min for f of x, the range of f and x. Well, that's also saying what's the maximum, what's the minimum on the graph. So if I've got 2 sine, I'm going to forget the phase shift, so that doesn't really affect it just now. If I'm saying I've got 2 sine of x, well, that's going to be like this, isn't it? It's a classic sine graph that goes up to 2 and to negative 2. If I move that up by 5, okay, if I move that up by 5, this number is going to go all the way up to 3. So actually, maybe I'll just draw this again over here then. So that's now going to go on to 3. Okay, so call that 3. And this number is going to go up by 5, it's going to go to 7. So the max and the min for this one is going to be, whoops, I've actually drawn a cost. Why have I drawn a cost one in there? That's funny. Sorry, 2 and negative 2. Sorry, that's weird. 2 and negative 2. How bizarre. But now it's going between 3 and 7. So it was before it was 2, if that was just 2 on its own, but now I've moved it up by 5, so it's going up to 3 and negative 7. And the middle would be in there at 5, wouldn't it? So it's doing something like that, down to 3 and up, where the middle's 5. Before the middle was 0, so that's gone up by 5 as well. So everything is adding on 5 from the 2, that's gone up by 5, that's gone up by 5, and that's gone up by 5. So that becomes our 7, 5, and 3, just like over here. So what's the range of values that we could have? Well, f of x could be anything in between 7 and 3, couldn't it? Anything in between 7 and 3. Not any lower than 3, not any higher than 7, so it's stuck between 7 and 3. Yeah, I quite like that question. Again, it makes you think a little bit about what's happening. It's not as simple as the ABC. It's kind of getting you to think, oh, wait a minute, how would I visualise that? So I didn't help you by drawing a cost graph. But yeah, if you think of what's 2 sine x, the phase shift is left and right, so that doesn't affect our max and min. We're thinking, okay, I'll draw the 2x and add 5, so what's your max and min? 7 and 3. But it's just nice to try and visualise it, I think. So yeah, let's go on to the next one. Okay, last one then. So what is the equation of this curve? It's in radians, but it's very similar to last time. So we don't have a maximum or a minimum here. That's just 1 then, isn't it? So the max will be 1, and the minimum will be 1. So what should be, if you look, we're actually negative 2. So we should find that our nice cost graph is doing something like this. We should find that it's doing that, So negative 1 to 1. But what we've got is it's going up to 0 and down to negative 2. So it's been moved down. Draw that in, right? It's been moved down by 1. Okay, so B has to be equal to negative 1. The whole graph has gone down by 1. And it's pivoting about negative 1. Okay? So this whole thing, this whole wave, should be up here, but it's actually gone down 1. And this is the phase shift. This is moving left and right. So it should also start up here, shouldn't it? It should start on the highest point. So that there is really where we should be starting. That now looks at the cost graph, doesn't it? But it's been moved. Yeah. So the graph has been shifted over. Let's see, that really should be back there, which means the graph has moved to the right. Okay. My graph has moved on to the right by this much, which means that this value in here, the plus a, the a, is going to be negative pi over 6, because when we've got a negative in the bracket, we move this way. That's negative in the bracket. When we've got a positive in the bracket, we move that way. And that's how much we've moved by. So it should start there. That should be over there. But the whole graph has just been shifted over to the right. Okay, so remember that with your phase shift as well. We talked about the heights and the plus and minus. At phase shift, you're almost doing the opposite, because it's the positive section of the graph, isn't it? The positive section of the Cartesian plane. So you would almost think I'm adding on that, but it's the opposite you do. It's kind of similar when you draw your sketches. Inside this bracket, we do the opposite. So if it was 2x, we divide it by 2. So here it's the same. The negative means we're moving to the right. So yeah, that pretty much covers everything about graphs. Much easier, less working than the other one. So yeah, your first number is all about the height, the last number is about moving it up and down, and this one's your phase shift. So a takeaway will move it to the right, and a positive will move it to the left. This one's been shifted onto the right, so that's why it was a negative. And yeah, hope that was helpful. Let's zoom out to just look at what we've covered so far then. We've done the addition formula at the top. We did a series on that, which was your Pythagoras to get the lengths, and then you were subbing in the ratios from the triangles into your addition formula, which you're given. They were quite nice questions. And then we were building up or solving the trig equations. So just from this very easy ones like this, where you had, say, oh, computer seems to have been dying on me. Yeah, like this, where you've got 2 cos x, to the slightly trickier ones where you've got to do your formula and then do the factorizing, and then finally with the graphs as well. Talked about the height, the period, and moving up and down. So I hope that was helpful. Thanks for listening.